Okay, good morning. So today I'm going to discuss one main important point in our physics exam. So here I have drawn displacement time graph. So here what I'm trying to do is I'm trying to get the velocity time graph using the displacement time graph. Okay, I'll discuss this later. So here we are trying to get the reverse process of that one. That means we are using velocity time graph to plot the displacement time graph. So in here, initial displacement is 0, and with time what will happen, the displacement is increasing gradually. Okay, so then according to the displacement time graphs, we are telling, so this has a constant gradient and I am taking this gradient as positive 1. Okay, so then we know from the gradient of a displacement time graph, we are getting the velocity. So here, from here to here, the gradient is constant. That means this should be a positive constant velocity. Okay, so then here what will happen is the displacement is keeping constant for this time period. Okay, so if the displacement is keeping constant, that means the velocity is 0. That means there is no velocity there. So then from here to here the gradient should be 0. That means the velocity should be 0 there. Okay, so initially it has a positive gradient and it's an constant gradient, so that's why we are taking this velocity as a constant one. And here in the final part what will happen, the displacement is decreasing again back to 0. Okay, that means the vehicle, if we are taking the real incident there, the vehicle should change its direction to the opposite direction. That means the direction of velocity. So here we have taken the velocity as a positive 1, as the gradient is positive here. So here the gradient is negative. So then in this part we will get some constant velocity, but it's to the negative direction. Okay, and here there is another thing. So here we can see the gradient in that part is greater than the gradient in that. I'll take this as alpha, I'll take this as beta. So we can see alpha is greater than beta. So that's the reason I have taken this velocity as v1. If I am taking this one as v2, v1 should be greater than v2. Okay, so this is the process. We are going to generate velocity time graph using a displacement time graph. Okay, so here when they are in exam, when they are giving questions for the MCQ part, what they are trying to do is, in some questions they are giving the displacement time graph and they are asking us to select the velocity time graph. And there is another process, they are giving the velocity time graph and they are asking us to select the displacement time graph. So then I'll move to the next part, that means the reverse process of this one, to plot the displacement time graph using velocity time graph. So here this is different. Here what has happened, velocity has decreased from a value to 0. Okay, velocity has decreased there. That means here that should be a deceleration. I'll write it here. It's a deceleration. Okay. Though it is a deceleration, displacement is not going to decrease. That is increasing. The reason is there is some velocity there. Okay. When there is a velocity, definitely the velocity makes a displacement. Okay, so due to that, what will happen? If I am taking the initial point as displacement 0 point, that should start from here. But here there is an important point. The gradient should be decreased. What is the reason? The velocity is decreasing. In the previous part we discussed, from a displacement time graph we are getting the velocity from its gradient. So that means here when it is moving to here, moving from here to here, the gradient should be decreased. So if the gradient is decreasing in a graph, that should be a curved graph. So I am taking this graph as, okay. So you can see initially there is a higher gradient, and when it is moving to there, the gradient is going to decrease. And here we can see the velocity is 0 here, so then definitely at that point the gradient should be 0. Okay. So then I move to the next part. In next part we can see here the positive velocity is there, and from here to here what has happened, the velocity is increasing, but this is the negative axis, velocity is increasing to the negative axis. Velocity is increasing to the negative axis means the object has changed its direction. So here velocity has decreased to 0, so then velocity is increasing to the opposite direction. The reason is this is negative part. Okay, so if the velocity is increasing to negative direction, the displacement, that means the direction of motion should change there. So then this is starting from here, and again it will come back to the same opposite direction. That means it will come back to the initial location. That means this shouldn't go like this. Here also velocity is increasing, so when we are moving from here to here, the gradient should increase there. Here the gradient is 0, okay, and from when it is moving from here to here, gradient has decreased. And there is another thing. So if their areas are equal, it should go some displacement here, and from here to here it should do the same displacement. That means the total displacement is 0 there. If we are taking the total displacement, it should be 0 there. The reason is here the area is a positive one, here the area is negative one. So that means we can get the displacement by calculating the area of a velocity time graph. Okay, so here there are two main MCQ points. So normally if we are looking at the past papers, we can see there are a lot of MCQs. There are 5 or 6 MCQs we are getting from this part if we are taking 10 past papers. So then to get this part, the main point is we should have the capability of plotting the graph according to the displacement time graph, and if they have given the velocity time graph, we will be able to draw the displacement time graph. Okay.